In order to talk about Gauss's law, first I need to introduce the concept of electric flux. The electric flux is the amount of electric field passing through a surface of area A. Charge creates the electric field that is responsible for the electric flux. The sum of all enclosed charges contributes to the flux. The formula to find electric flux is shown. The electric flux for a closed surface, like a cube or sphere, is found by using the second equation. The electric flux through any closed surface is independent of the shape of the surface. The net electric flux is zero through a closed surface that does not contain any net charge. In other words, field lines that start outside of the surface will have zero effect on the total flux. However, if a field line starts inside of the surface, it will have a net effect on the total flux. Now let's talk about Gauss's law. Gauss's law will allow us to find the electric fields of some very important and very practical charge distributions. The Gaussian surface has the same symmetry as the electric field. Gauss's law states that for any closed surface enclosing total charge Q enclosed, the net electric flux through the surface is shown by the equation below. Gauss's law states that charges create electric fields in a way that the net flux of the field is the same through any surface surrounding the charges, no matter what its size and shape may be. There are some necessary requirements in order to use Gauss's law. It only applies to a closed surface, called a Gaussian surface. The Gaussian surface is not a physical surface. It is an imaginary mathematical surface in the space surrounding one or more charges. We need to apply Gauss's law in situations where we already can guess the shape of the field through symmetry and superposition. Gauss's law is only effective in a limited number of situations where the field is highly symmetric. When using Gauss's law, choose and draw a Gaussian surface with the same symmetry, and be sure every part of the Gaussian surface is either tangent or perpendicular to the electric field.